Okay, Chapter 9, Question 1. This semester here, our cat was named Carl. You might have a different name for our cat, but Carl's riding a skateboard. He's going across campus at around 4.5 meters per second. That's his velocity. Skateboard comes to a stop after 7.9 seconds. Total mass of the skateboard and the cat is 17 kilograms. In this case, we want you to use momentum to calculate the average friction force that must be acting on the skateboard. So remember here that force, Newton's law, says that it is the derivative of momentum over time. Or if you're looking for an average force, it would be that change in momentum over change in time. So this is the hint here it gives you on what this is. So the change in momentum is equal to force times the change in time, so we can rewrite it that way. So we'll start with this. We'll look at what the change in momentum is. Okay. So the force here that is being acted on is friction. It's the impulse that's occurring that's slowing it down. So our friction force, Ff, would be equal then to the change in momentum over change in time. Change in momentum would just be mv final minus mv initial over the change in time, and it says here it comes to a stop in 7.9 seconds. So this one would be 7.9. Okay. If we keep going with this, we know that the mass of the skateboard and the cat is 17 kilograms. So I can have 17 for the mass. The final velocity, in this case, it says it comes to a stop. So 17 times 0, okay? Minus 17 was the mass originally, and the initial velocity was 4.5. Okay, so we divide that all by 7.9. 17 times 0, of course, just is 0, so that just cancels out, leaving us with a negative number here. So let's do that calculation quick and see what it is. Okay, so 17 times 4.5 divided by 7.9 should give you a friction force equal to negative 9.68, and that's in newtons. And of course it's negative because it's going in the opposite direction. All right, so the friction force always points in the opposite direction, and that agrees with our answer up here.